Okay, today we're going to talk about circles and arcs. We've talked about circles just a little bit. We're going to really, the next few sections, really dive into circles. So first thing, let's review some vocabulary that will be very helpful when talking about circles. So first thing, a circle is the set of all points equidistant from a given point, which I don't really think I ever thought of a circle that way. But you think about it, you have a point, okay, like a center point, and you go out 3 inches, and then you go out 3 inches this way, and out 3 inches this way, and out 3 inches, it's going to create a circle, which is kind of interesting, okay? Now that given point is called the center. Now, we name a circle by its center. So we are going to talk about a little bit new notation, a little bit new ways to name things with circles. So the first notation, most of the time you're not going to say the word circle P. You're going to see an actual circle with the dot in the middle and then a capital letter. So this means circle P, which means that center point is point P. Okay? Now, if we talk about these different parts of a circle here, then we'll kind of go into the more new stuff. This is stuff you've probably heard before. So P is the center of the circle. The diameter of a circle is the distance all the way across. And then if you go from the center straight out to the side, that's the radius. Okay? You could go from the center straight out to any side. That radius is always going to be the same. Same thing with the diameter. As long as you go through the center, that diameter is always going to be the same for any circle, or for that given circle. Okay? Now what we're going to be talking about today a little bit are the angles that you can create in a circle. We talked about it a little bit before spring break with a polygon and how whenever we drew from the center out to all of the vertexes, we called kind of the central angle, we said like 360, that central angle. So just kind of really putting a name to a picture here. So the central angle is going to be created by points on the edge, and the middle point, that vertex, is going to be the center. So in this case, angle APC would be a central angle. Now, this stuff is probably not a whole lot new. Hopefully at least somewhat familiar. But what we're going to start talking about today is probably going to be new, that even if you have learned about this before, probably kept it to a pretty minimal thing. So what we're going to be talking about today is not necessarily the entire circle. We're just going to be looking at parts of this circle. And specifically, not like a chunk of the circle. We're just talking about the outside of the circle, okay? So when I talk about a chunk of the outside of a circle, or just a part of a circle, that is called an arc. An arc. So if I look at the entire circle, and once again, we're not talking about the outside and what's inside. We're just talking about the outside of the circle, okay? If I were to just take a chunk, that's called an arc. If I were to take half of the circle, okay, that is called a semicircle, which we've probably heard before. A semicircle, half of the circle. Now, if you take that semicircle and use that to compare other arcs that I can create, if I have an arc that is smaller than a semicircle, so less than half of the circle, this is called a minor arc. A minor arc is basically less than half of a circle. If I wanted to talk about more than a semicircle, larger than a semicircle, that is called a major arc. Okay, so a minor arc, smaller than a semicircle, a major arc, larger than a semicircle. Now, how we name arcs, how we name arcs is going to depend on whether it's a minor arc or a major arc. To name a minor arc, you're going to name it similar to how you would just name a segment. So, for example, if I were to look at this picture here, this red segment, I know yours isn't colored copy, but you can see it on the board, that this red part of the circle here, that red arc there, that's a minor arc, because it's less than half of the circle, okay? To name a minor arc, you just use the endpoints. So the endpoints are R and S, so you would call it arc RS. Now, if you notice the notation, it kind of since it's kind of small, it almost looks like a line over RS, but it's not. It is an arc over the RS. Okay, that's how you're going to know we're talking about a circle and talking about an arc. Now here's the thing. In relation to R and S, there's a minor arc and a major arc associated with those two endpoints. You can see the minor arc, it's RS, but if I wanted to talk about the major arc, right, going around the other way, I can't call it RS, because RS is a minor arc. So to name a major arc, you are going to use the endpoints, but you also have to use another point on the arc. So you could call this arc STR, or you could go the opposite way and call it RTS. So a minor arc, you just use the endpoints, okay? Just the shortest distance between those two. But a major arc, you have to have 3 points, 3 letters, and they have to go in order, okay? So you couldn't say RST, that wouldn't go in order, okay? So that actually would be a different one, okay? All right, so coming down here, a couple different things we're going to talk about today. When we talk about the arc measure, this idea is really pretty simple. So the arc measure, if you're talking about a minor arc, so an arc smaller than a semicircle, so for example, in this picture right here, I could talk about the minor arc RT. If I wanted to talk about the measure of arc RT, that notation is going to look really similar to like when I would talk about the measure of an angle, right? We'd say measure and then angle. So if I wanted to talk about the measure of angle RT, it's going to be the same as the measure of the corresponding angle. So what I mean by that, RT, the corresponding central angle, if it says it's 50 degrees, the measure of arc RT is also going to be 50 degrees. Now, to find the measure of a major arc, okay, so in this case, if I wanted to find the measure of arc, 2 ways you can name this. You can name it TQR, remember you have to have 3 because it's a major arc, or you could go the opposite direction and call it RQT. Either way means the same thing. But if I wanted to find the measure of that major arc, okay, if you just think about it, all the way around the circle would be 360, okay? So I know that that little chunk is 50, so yeah, we're going to take 360, which is all the way around the circle, minus that 50 degrees that's in that other arc, and it's going to be 310. So it's the rest of it. So it says the measure of the related minor arc. So going the other way around the circle, just subtract that from 360. Okay, so sometimes whenever we're finding the measure of a major arc, we're going to do that. But other times, to find the measure of a major arc, we might be taking 2 other arcs and adding them together. And we can do that because of the arc addition postulate, which should sound kind of familiar because we've talked about the segment addition postulate, where I have this segment plus this segment equals the whole segment, or the angle addition postulate, where I have this angle plus this angle equals the big angle. Remember doing all of these things, which maybe at least sound kind of familiar. You do the same thing with the arc. So the measure of an arc formed by 2 adjacent, so 2 arcs right next to each other, you can add them together, they would give you the big arc. So in this example here, if I wanted to find the measure of that whole arc, okay, if I wanted to find the measure of arc ABC, the measure of arc ABC, I could take the measure of arc AB, so that little chunk right there, plus the measure of arc BC. Add it to that one. So sometimes when we're finding the measure of arcs, we're going to have to approach it from that way. You can add those 2 arcs next to each other together. And then the last thing we're going to talk about today is how to find the circumference of a circle, which we have done a little bit. We're going to keep it pretty simple today. So circumference, I kind of think about circumference as perimeter. I mean, right, because we're talking about perimeter of a shape, we're talking about the distance outside. That's exactly what the circumference is. It's the distance around a circle. So to find circumference, there's two ways you can find it. It just depends on what information you're given. So the two formulas to find the circumference, you can either take pi times the diameter, which is all the way across, or you can take circumference equals 2 pi r. Because, if you kind of rearrange things, you put 2r next to each other, two radiuses would give you the diameter, right? So same formula, but it just depends on what kind of information you're given. Okay, what we're doing today is really pretty simple. Okay, you guys have questions on any of that? Okay, let's get this glued into page 41, section 10.6, and it is circles and arcs. Okay, so the first thing we're going to do is we're just going to practice naming different things. We're going to practice kind of looking at the notation. Now, in your textbook, it's not going to name the following in circle P. You're not going to see the word circle, but I can get that symbol. Anyway, you're going to see a circle with a dot in the middle of it and the letter P next to it. That's the notation for circle P. Okay? So let's go ahead and let's draw a circle with a center point P. And then we're going to draw a couple different segments here. Let's draw a diameter with endpoints R and T. Then let's draw a radius to endpoint S. And then on the other side over here, let's do a radius that is Q, and then a radius that is U. So we're just going to practice how to name different types of arcs. So what we're going to do here, in these directions here, is going to be the same thing you guys are going to do in your homework. So in your homework, just a warning, the directions say name all minor arcs. I tried to do that. I was like, oh, there's this one, and it never seemed to end. Of course it does. But what I'm going to do is I'm going to change the directions a little bit. It'll be the same thing when you get to your homework. I want you to name 3 minor arcs. And you guys will kind of see as we start naming them how many there are. And then you can flip the letters and it's kind of a new way to name things. So instead we're just going to name 3 minor arcs. Now, as a reminder, a minor arc is an arc that is smaller than a semicircle. So a semicircle would be halfway around the circle. So I'm looking for something that is less than half of the circle. And remember, we name minor arcs using their endpoints. So, anybody have a minor arc? What's that? ST. Very good. ST. Less than half of the circle. Now, as a reminder, how we name it, you do capital S, capital T, and then put an arc over the ST. What's another one? RQ. Yeah, that would be a minor arc. One more. TU. Yep, TU. That would be a minor arc as well. And notice, and this is where it can get a little confusing with the minor arcs. They don't have to, there can be a letter in between them that you could skip. So for example, QT. Is that less than half of a circle? Less than half of a circle? Yeah, it is. And I skip U. That's fine. You're just using the endpoints. So that would be a minor arc as well. You could do the same thing with SQ. You could do R. See how many there are? Keep going. Okay, and then you could even flip the letters, and it would just be a different name scheme. So that's why we're just name 3. Okay. So even the directions in your homework, just name 3. We'll do the same thing here. Let's name 3 major arcs. Same thing. In the directions, it's going to say name all of the major arcs. I just need you to name 3. Now, before we start naming these, when it comes to naming purposes, how is naming major arcs different than naming minor arcs? You have to have 3 letters. So you are going to have the endpoints. But for example, if I tried to say arc ST, ST's the minor arc. But if I wanted to name the major arc, okay, going the other direction, you are going to use ST, but you have to have a point in between it. So there's a couple different ways to name this one, right? How could I name the major arc between S and T? T-U-S. Very good. T-U-S. Or you could do S-U-T, or you could do T-Q-S, or S-Q-T. See all the options here? Okay. What's another major arc? Elijah? S-Q-T, which is actually the same arc we just did, isn't it? S-Q-T, that is going to be the same arc. So that would be another way to name it. Could we come up with a totally different arc? Gabby? R-S-U, very good. Got to go more than halfway around the circle. R-S-U, very good. Like a huge one, like almost the whole circle. R-U-S. Almost all the way around the circle. Very good. R-U-S. Very good. Totally different options there, okay? When you're on your homework, just name 3 of them, but try to name 3 totally different arcs, not just like the same arc named different ways, okay? And then the last thing, once again on your homework, it's going to say name these semicircles. I just want you to name 1 semicircle. Which really there should just be 2 of them, one going one way, one going the other. But we'll just name 1. What is a semicircle here? Very good. R-S-T. Yep. R-S-T. Okay. Questions on the naming? Okay. Now let's move on to talking about measures. So we want to find the measure of each arc in circle K. So let's go ahead and draw circle K, which remember, circles are named off of their center. So whenever I say circle K, I already know that center point is K. Let's go ahead and draw a diameter with endpoints X, Z. Okay, we're going to draw a radius that's actually going to be perpendicular, going out to point W. And then we're going to draw another radius out to point Y. And this measure down here is going to be 103 degrees. Now, what I would suggest to you, what I think is going to be the easiest thing to do, we are probably going to end up eating all of these angle measures. And I know some of them, right? I know that one's 103. If I were to talk about this angle here, what does that angle measure? 90. What about this angle? Also 90. Right? It's a straight line, perpendicular lines. How would I find this other angle here? Subtract 103 from 180, right? It's a straight line. So 180 minus 103 would give me 77. I think it's going to help to find those angles beforehand. And in that way, whenever you go to find your angle measures, they're already there. You've just got to kind of match them up there. Okay, so number 4, we want to find the measure of each arc. So let's find the measure of arc WX. The measure of arc WX. Now remember, the measure of an arc is the same as the measure of the corresponding central angle. So the measure of this arc is going to be the same as the measure of that angle. So what is the measure of my arc? 90. Okay, now what if I wanted to find the measure of angle, sorry, not angle, the measure of arc xy. Like I said, I think sometimes it helps since we went ahead and we already put our equal measures there. What is the measure of arc xy? 77. The minor arcs usually are pretty simple. Sometimes have to work a little bit harder for the major arcs. So let's say we want the arc WXZ. WXZ. So if I were to look at this WXZ, I can see that it is a major arc because I'm going more than halfway around this circle. And I think with major arcs, there's two ways you could find the measure of this major arc. What's one way? We could just use the arc addition postulate. We could take 90 plus 77 plus 103. That's one way. What's another way? Okay. Exactly. All the way around is 360. That is 90. Either way, it's not going to matter. If you take 90 plus 77 plus 103, or if you take 360 minus 90, either way you're going to get 270. Doesn't matter. And let's do one more of those. So number 7, let's find the measure of arc YCW. YCW. So YCW. How are we going to find the measure of this arc? This one you're going to have to do the arc addition postulate, right? Because I know that this arc plus this arc is going to equal all of it. So 90 plus 103 would be 193. Questions on finding the measures of arcs? Yes. So one of the things, and this was like I think the very first day of geometry, one of the things you can assume is a straight line. So if it looks like a straight line, you can assume it is a straight line. That's one of the things we can assume. It's a great question. Okay, last thing we're going to do is finding circumference. Now this says to leave your answer in terms of pi, which means to find the circumference, there's two ways. You can either take pi times diameter or 2 pi r. It just means you're going to leave the pi as pi. You're not going to approximate, not turning it to a decimal. Just leave it as pi. So number 9, let's draw a circle that has this dimension of 3 feet. Okay, remember we have 2 formulas. We have pi times diameter or 2 pi r. Which one will I use here? 2 pi r, because this is a radius. So we would take 2 pi, and my r is 3. Now I said leave it in terms of pi, but you do want to simplify if you can, because this is just multiplications. 2 times pi times 3. I can rearrange this. And I can take 2 times 3, and I want to call it 6 pi. Now, as always, we want to use units. What are the units going to be for this? Feet. Feet squared. Or feet cubed. Which one? We have 3 options. Feet, feet squared, or feet cubed. Should we vote on it? How many of you think it's feet? How many think it's feet squared? Feet cubed? Okay, only one of you got it right, and it was Andrew. It is just feet. Andrew, can you explain why it's just feet?
It's just distance.
It's just distance. Yeah, it's just distance. So squared is the area, right? That would be the area inside. This is just the distance on the outside. Cubed would be a volume, right? So we're not talking about that until next chapter. So circumference, it's just a distance. Anytime you're talking about a distance, it's just your normal units there. Okay, and then last one, Let's do a circle that has this dimension of 10 inches. So will I use pi times diameter or 2 pi r? I probably use pi times diameter because that's just the diameter, even though script touched all the way across. So if I take pi times diameter, I get 10 pi. So I'm going to leave it in terms of pi, and then we'll throw the inches on there at the end.